Hey friends, this week we're going to review multiplying and dividing fractions. At the end of the week, you'll have the opportunity to retake your Topic 11 test in Envisions. In order to retake your Topic 11 test, however, you must have completed 3 sets of practice problems, the first of which we're about to begin now. Set 2 will be posted on Tuesday and set 3 will be posted on Wednesday. Okay, let's go ahead and get started. How many 2/3 are in 6? And then this number here just is telling you which Envisions lesson this is talking about. So in topic 11-10, if you wanted to go back and rewatch that lesson, you could find it in 11-10. Okay, so we're looking to count groups of 2/3. So I want to count 2 out of every group of 3 and figure out how many I end up with. So the first thing we're going to do is write an expression that represents the question. We're going to solve 6 divided by 2/3. Now, in order to solve this expression, I'm going to count up how many groups of 2/3 I have in 6 wholes. I know that when I divide a whole number by a fraction, I'm going to end up with, surprisingly, an answer that's bigger than what I started with. So 6 divided by 2/3 can be visually shown like this. So here's, let's see, 1 group of 2/3, 2 groups of 2/3, here's 3 groups of 2/3, 4 groups of 2/3, 5 groups of 2/3, 6 groups of 2/3, 7 groups of 2/3, 8 groups of 2/3, and 9 groups of 2/3. So 6 divided by 2/3 equals 9. If you're looking for a faster and more efficient way to solve that, you can multiply by the reciprocal. 6 will remain the same, and then I'm going to multiply by 3 halves. The reciprocal of 2/3 is 3 halves. When I do that, it might be easier to rewrite your whole number with a denominator of 1. It doesn't change the value of the number 6, but it does put it in the form that we can kind of easily work with when multiplying fractions. When multiplying fractions, remember that you simply multiply the numerators. 6 times 3 is 18. Multiply the denominators. 1 times 2 is 2. And in this case, we can simplify this. 18 halves, that's the same as 18 divided by 9, because the fraction bar is also a division symbol. Oh, sorry, I said that wrong. Verbal typo, my bad. 18 divided by 2, because 2 is my denominator, and 18 divided by 2 is 9. So the answer is D9. Jocelyn reads 6.5 pages each day. Which of the following can be used to find N, the number of pages she will read in a week? And this skill comes from lesson 11-12. So if you need to go back and rewatch that video, I suggest you do that. Now, when we look at the diagram that they very helpfully provided for us here, we can see that this line here represents N, the total pages that she read over the course of a whole week, or 7 days, right? 1, 2, 3, 4, 5, 6, 7, okay. Since she read 6.5 pages each day, This looks a lot like repeated addition to me. 6.5 plus 6.5 plus 6.5 plus 6.5 plus 6.5 plus 6.5 plus 6.5. Now, a more efficient way to represent that would be by multiplying 6.5 pages each day times 7 days in a week for a total of n, the total pages Jocelyn read all week long. So which of these expressions looks like it matches that? Looks to me like C most closely matches it. 7 times 6.5 equals n, her total number of pages. The only difference is that my two factors are reversed, and we know that that doesn't matter in a multiplication expression. Okay, now, reminder, the best way to learn from a math video is to take notes and work the problem along with me. You should be pausing the video as you work, just to give yourself time to catch up, and then unpause the video and compare your work and your solution with what I'm showing you. Number 3, Connie and 2 of her friends completed a 10-mile bike relay. Now, I always think that drawing a quick sketch is a great way to visualize and understand what's happening in a problem. So here we have Connie.
She needs a face.
You're right, she does need a face. And 2 of her friends. One friend is having a really bad hair day, but it's okay. All right, so here's Connie and 2 of her friends, and they completed a 10-mile bike relay. So 3 people all together were participating. 3 people. Each friend rode an equal part of the race. What distance did each friend ride? Now, a relay, if you're not familiar, it's kind of like a race where everybody has a part to do. So that's why they're telling us that each friend did an equal part. We're going to take the 10-mile bike relay race and divide it into 3 equal portions. 1 portion for each of the 3 people participating in the race. So we're doing 10 divided by 3. Now we can represent this with a tape diagram. Okay, so here is her 10-mile relay race, and I can divide it into portions for each friend. So each friend is going to complete 3 miles and 1/3 of a mile. So we're going to take this final mile here and divide that final mile into 3 equal pieces. If I can grab it and make it a little bit, okay. So 1 remaining mile divided by 3 equal pieces gives us 1/3. Okay, so 10 divided by 3 equals 3 1/3, which is here. Number 5, Mrs. Webster wants to divide the milk shown into servings that are 1/3 of a pint in size. How many servings are possible? This skill is from lesson 11-10. So you can go back and review that lesson on Envisions if you need to. So she's going to take her 5 pints of milk and divide it into thirds. If we take 5 pints and divide it into thirds, how many thirds will we have? Look at our answer choices. They're all bigger than 5. And that's because when we take a whole number and divide it by a unit fraction, such as 1/3, we end up increasing the amount we started with. Okay, so here's, let's see, we'll call that 1 pint. Okay, so here's her 5 pints of milk, and we're going to divide each one into thirds. And when we count up our thirds, we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, I should have 15. All right, 15. All right, now if you want a quicker, more efficient way to do it, you can multiply 5 wholes, put it over 1. It doesn't change the value of your fraction, but it makes it easier to work with, times the reciprocal of 1/3 is 3 over 1. Multiply your numerators. 5 times 3 is 15. Multiply your denominators. 1 times 1 is 1. And 15 over 1 is simply 15. So here our correct answer choice is C, 15. Number 6. Jeff is making a tablecloth that has 4 sections, each of which is 1 3/8 feet wide. What is the width of the entire tablecloth? So if we represent his tablecloth with this rectangle, okay, and it has 4 sections, each of which is 1 3/8 wide. Okay, so if this first section is 1 3/8, and our second section is also 1 3/8, and so is our third section, and so is our fourth section, what does that look like to you? Does that look like repeated addition? If you said yes, you are absolutely right. So we're going to do 1 3/8 times 4. And when we multiply 4 times 1, we just get 4. That's easy. And when we multiply 4 times 3/8, we can do that like this. 4 over 1 times 3/8 equals 4 times 3 is 12. We just multiply our numerators. Then we're going to multiply our denominators. 1 times 8 is 8. That gives us 12/8, which we can simplify to 8/8 or 1 whole plus 4/8 or 1/2. That gives us a mixed number value of 1 and 1/2. So I'm going to take the 4 that I started with when I did 1 times 4, and to that I'm going to add 1 1/2. That gives me a total of 5.5 feet. This little dash here represents feet, which is here. Number 9, a wall in front of a house is shown below. If 3/8 of the wall, sorry, I read that wrong. If 3/5 of the wall is made from brick, how do you determine the height of the brick portion of the wall? So you can see from the diagram that part of it is stone and part of it is brick. And it looks like the bigger portion is brick, and then there's less of it that's made of the stone. So this portion here, that's the 3/5, that's brick. Now we're trying to figure out the height of the brick portion. So what we're going to try to do is we're going to calculate 3/5 of 7 3/4. Since we're going to calculate a portion or a part of 7 3/4, I'm going to be multiplying. 3/5 times 7 3/4. Okay, now you have two choices here for how you can multiply this. You can multiply 3/5 times 7, like this, and then add to that 3/5 times 3/4. You can do it that way. So let's do option 1 and then I'll show you option 2. Okay, so 3/5 times 7/1. Multiply your numerators. 3 times 7 is 21. Multiply your denominators. 5 times 1 is 5. So that gives us 21/5. Don't worry about converting that to a mixed number yet. Then to that, we're going to add 3 times 3. Multiply your numerators. So 3 times 3 is 9. I wrote this really messily. I'm sorry. This is a 5. Okay. 5 times 4 is 20. So that gives me 9/20. Now I've got to go to the effort of finding a common denominator to add these, because I can't add fifths and 20ths. That's like trying to add apples and oranges. It just doesn't work. So if I'm going to do that, let me see. My common denominator is going to be 20. So I need to convert 21/5 to some number out of 20. 5 times 4 gives me 20. So I need to multiply both my numerator and my denominator by the same number. 21 times 4 gives me 84, I believe. Okay, so I've got 84/20 plus 9/20. Oh Lord, okay, 84 plus 6 gives me 90, plus 3 more gives me 93. Is that right? Yeah, that seems right. Okay, over 20. Now I've got to convert that to a mixed number. Remember, you should be pausing this video and working the problem along with me. So go ahead and pause me and figure out what this is going to be as a mixed number. Now that you're back, hopefully you figured out that 93/20 is the same as, let's see, 20/20, that's 1 whole, plus 20/20, that's 2 wholes. So far I've got 40 out of 20 represented, plus another 20 out of 20, that's 3 wholes, plus another 20 out of 20, that's 4 wholes. So let's see, 20, 40, 60, 80. That leaves me with 13. Oh gosh. 13 out of 20. Okay, so my mixed number is 1, 2, 3, 4, and 13/20. Then all of that. But we got the same answer. Okay, now I'm going to show you option number 2 for solving this. If you want to calculate 3/5 of 7 3/4, this information is not needed. We don't need that. That's kind of more just like a distractor. If I'm trying to calculate 3/5 of 7 3/4, another way to do that would be to go ahead and convert this to an improper fraction now, and then go ahead and do my multiplication. So 7 3/4 as an improper fraction, here's how I'm going to do that. I'm going to multiply 4 times 7. That gives me 28. So I'm just going to mark that with a little times symbol here. 7 times 4 is 28, plus 3 more. That gives me 31, and then my denominator stays the same. I'm not going to explain this process that I just did right now. We're going to talk about this during our live lesson on Monday. But just keep in mind, this is a more efficient way to do it. If you have a good procedural memory and you can remember, multiply your denominator times your whole number, then add your numerator. We'll talk about that during our live lesson. Okay, now 3 times 31, that gives me 91. 5 times 4 gives me 20. And then I just have to convert this to my mixed number. So see how that was just a faster process, except that I made a tiny mistake and this should be 93. My bad. 93. Okay. So 93 divided by 20 gives me 4 and 13/20. Okay, this next question asks us to estimate. We're going to estimate 3 1/3 times 4 1/8. Now, I know 11 is too small because 3 times 4 is 12, so my product needs to be at least 12. And 16 and 17 seem too big to me. So I'm going to go with 12. When it's a problem about estimation and it's a test question, if estimation is not something that you feel super confident about, here's my suggestion. Go ahead and solve and find the product or the answer, and then choose the estimate that is closest to the actual product or the actual answer that you got. That's my workaround for you guys who are not very confident with estimating. I mean, estimating is a really helpful skill in life, but for a test question, if you're trying to get the right answer, that's one way to kind of work your way around it. Here's another estimation question. We're going to estimate the product for 28 2/3 times 4/5. If I flip-flop those factors around, it makes it easier for me to think about. I'm trying to find 4/5 of 28 2/3. That means that I'm going to take a portion of 28 2/3. So my answer needs to be smaller than this factor here. That tells me that my answer is going to be either 20 or 14. Now 4/5 is bigger than 1/2. It's most of 1 whole. So if I take most of 28 2/3, I think my answer is going to be, it makes more sense to me that it would be 20 rather than 14. If this kind of reasoning does not feel natural to you and you're not sure, on a multiple choice question about estimation, your best bet is to calculate the exact answer and then choose A, B, C, or D based on which estimate is closest to the exact answer. Okay, so that is set 1. Thank you for staying with me. I'm sorry this video was so long, but I'm proud of you for sticking with it. And we're going to keep working on this week, and then at the end of the week, you can retake your topic 11 test if need be. Have an awesome day, and let me know if you need me.